video, we're going to discuss applications for Venn diagrams. So the specific application we're going to look at is the survey type problem. So the idea is you're administering a survey, you're collecting data, and you can think of a Venn diagram as a way to organize your data in a meaningful and a visual way. So we're going to start by essentially defining sets that relate to the regions in our Venn diagram. Now, the way we interpret our results from our sets, from our survey, from our Venn diagram depends on the wording that's being used, just based on the kinds of questions we're being asked. So think of specific words as being red flags to tell you what sort of regions you're looking at in your Venn diagram once you create it, once you label it. So whenever you see the word and means you're looking for an intersection. Now the word but also is interpreted in the same way. So English, and but mean two very different things. But in terms of what they mean based on looking at a Venn diagram, based on identifying regions, based on the wording, the and the but both mean we're looking for an intersection within the diagram. Now, when we see the word or means we're looking at a union. Now, we also have to think about or in terms of what it really means, because there are a couple different meanings for the word or. There's what we call an inclusive or, and there's what we call an exclusive or. So inclusive or means one or the other, and possibly both. So if something falls into one set, it's included in the union. If something falls into another set, it's included in the union. And then any things that fall into both sets, those are also included in the union. Now the term exclusive or means one or the other, but not both. So that's not going to be the or that we're talking about when we use the word or in terms of sets, in terms of Venn diagrams. Now the other word we're going to look for is the word not. Whenever you see the word not, that's referencing the complement. Remember, the complement is essentially like set subtraction. So if you're taking the complement of a particular set, you're removing the contents of that set from the universal set, from the Venn diagram, if we're looking at a Venn diagram. Now, what we're going to talk about specifically is counting, taking the results of a survey, thinking about how many elements fit within a particular region in the Venn diagram. So we're going to look at counting. Specifically, the term we use for this is cardinality. So we used that term back at the beginning a few videos ago when we were talking about counting how many elements are in a set. So we're looking for the cardinality of specific sets. Now, one thing we do have to remember is the rule about unions. Counting a union, there's a little bit more we have to do. So if we're thinking about how many things are in one set or another, remember that means one or the other and possibly both. So we cannot just count how many items are in one set, how many items are in the other set, and then add them together. The issue with doing something like that is that's going to double count any items that happen to overlap, items that are in both sets at the same time. So whenever we want to count how many elements are in a union, yes, we are going to add the individual counts together, but we're also going to subtract the number of elements in those sets intersections so that these elements are not double counted. They're counted here, which means they're counted twice. So we subtract that count one time, and that's going to take us to the correct total. So let's look at an example where the diagram has already been drawn, it's already been labeled. Let's see if we can interpret what we're looking at from the diagram. So in a survey on musical tastes, respondents were asked, do you listen to classical music and do you listen to jazz? The results of the survey are summarized below. We want to use the diagram to answer the following questions. So here's our diagram. Here's all the data we have. We can determine a lot of different things from the numbers in this diagram based on where they are in the diagram. So we've labeled one set as classical music, and we've labeled one set as jazz, and in terms of what they mean, that's pretty self-explanatory. So our first question is, how many respondents listened to classical music? Now, we have to be careful here. We have to be very specific about our wording. This does not say how many respondents listened to only classical music. What it says is how many respondents listened to classical music. Another way to think of this is, once they were asked the question, do you listen to classical music? How many people said yes? That's another way to think of it. So we're not necessarily worried about how they answered the other question. We just want to know how many people would have said yes to the question, yes, I listen to classical music. Okay, so we have 55 in one region in the classical music circle, and then we also have 20 in the overlapping region. But notice both of those regions are part of that classical music category. So anyone who would fall within one of those regions is someone that answered yes to the question, do you listen to classical music? So the number of people who listen to classical music, that's going to be 55 plus 20, which is going to be 75. Next question, how many respondents listened to jazz? Same thing, it doesn't say only jazz, it says jazz. So in other words, when they were asked the question, do you listen to jazz? How many people answered yes? Well, 70 and then 20, those are going to be the numbers within those two regions representative of the jazz circle. So 70 plus 20, that's going to give us a total of 90 that answered yes to the question, do you listen to jazz? How many respondents listened to both? The word both here means we're looking for the intersection. It means classical and jazz at the same time. Well, that's going to be 20. That's going to be anyone who would fall within that overlapping region. So 20 respondents listened to both kind of music. How many respondents listened to classical music or jazz? Now remember we said the word or means union. So anyone who falls into the classical category or the jazz category and possibly both. The and possibly both part is what makes this an inclusive or. We're including that part as what we're thinking of as the union, as being one or the other. So classical music or jazz, everyone who listens to classical music is in the classical circle. Everyone who listens to jazz is in the jazz circle. So one or the other means we're joining them together. We're thinking of them as one unit. So that's going to be 55, 20, and 70. So 55 plus 20 plus 70 is going to give us 145. Now we have the rule for counting a union here, and this is what we just did. But why did we not have to use the formula in order to calculate how many individuals were represented in the union? The reason we didn't have to use the formula is because the diagram has already taken care of this issue for us. The individuals in the overlap, yes, they are in the first circle and yes, they are in the second circle. But based on how the diagram is designed, we only see that 20 one time. So we can think of that 20 as being within one circle and the other at the same time. But if we're just adding up the counts from individual regions, those 20 people are only counted one time. Now here's where we would have to potentially use that formula. Notice the first question, how many respondents listened to classical, and the second question, how many respondents listened to jazz. If we were to join those two together, then we're talking about the same thing. We're talking about the union. So classical or jazz would mean we're joining those two together. But if you were to take 90 and 75 and add it together, let's see what you would get. 90 plus 75 would give you 165. And we determined that the correct total is 145. So why do we get a different number here? Well, we get a different number because that 20 is double counted. So notice if you look at these two sums and you look at their totals, both of these totals include the 20 individuals that represented the intersection of those two sets. So those 20 were counted twice if we just add up the 90 and the 75. So we want to count them, but we only want to count them one time. So if we were going to determine the number of individuals in the intersection, or not the intersection, the union, this way, we'd have to subtract 20 to make sure that we didn't double count it. And that would give us 145, which is the correct total that we get from those three regions in the diagram. So if you're looking at just the diagram, you don't necessarily have to use the formula for counting a union. However, if you're going to work backwards and you have information about the sets and you want to use them to label the diagram, that might be a situation where you do have to use the formula. You may end up using it backwards. Okay, next question. How many respondents listened to classical music but not jazz? Okay, so classical music but not jazz. Now, not jazz, the word not means we're taking the complement. So we're taking the complement of the set involving jazz. In other words, we're removing that from the diagram. So how many respondents listened to classical but not jazz. In other words, they're in the circle for classical, but they're not within the circle that overlaps. They're not within the region that overlaps with the jazz circle. So that's going to be 55. How many respondents listened to jazz but not classical? Well, same kind of thing, but now we're taking the complement of the classical set. So they listened to jazz but not classical, so that's going to be 70. How many respondents listened to neither classical music nor jazz? Well, that's going to be anyone that was surveyed that said no to both of these questions. I don't listen to classical music, I don't listen to jazz. If we want to think more literally in terms of set operations, here's what's going on. Another way of saying this is they don't listen to classical music or jazz. Well, with classical music or jazz, remember that means the union. But if we're saying they don't listen to it, then adding in that not, adding in that negative part, means we're removing the union from the diagram. So in terms of people who listen to neither classical music nor jazz, that's going to be anyone that's left in the diagram that wasn't categorized into one of these sets. So that's going to be a total of 30 people. And then the last question, because this wasn't actually mentioned, we weren't actually told this, how many people were surveyed? Sometimes you'll be told what your total is for the survey. In situations where you want to work backwards and label your diagram, typically you're told how many people were surveyed. But if we already have a fully labeled diagram, we actually can determine how many people were surveyed. You have to think about what the different regions represent. They represent all 4 different categories that anyone can fall into based on how they answered the survey. So anyone who falls into this region said yes to classical music, I like classical, but no, I don't like jazz. Anyone who fell into this region said yes, I like jazz, no, I don't like classical. Anyone who fell into the middle said yes, I like and I listen to both. And anyone who fell on the outside said no, I don't listen to either type of music. Those are the only categorizations we can come up with for 2 questions. You either answer yes or no to one, you answer yes or no to the other. So there's 4 total possibilities. So every single individual that was surveyed ended up in one of these 4 categories. So if we want to know how many people were surveyed, all we have to do is add up how many individuals ended up in each category. And that's going to tell us what the total is for the actual survey. So 55 said yes, I listen to classical, no, I don't listen to jazz. 70 said jazz but not classical. 20 said yes to both. And then 30 said no to both. And that's going to give us a total of 175. So this total, once we start to work backwards, which is what we're about to do, what happens when we don't have the diagram to start with and we need to draw the diagram before we can actually determine anything. The total is going to be very important. So if we're given the total to start with, we're going to think of our total as the check for our Venn diagram at the end. We have to make sure that our Venn diagram is accurate and that it makes sense. So if we're given the total number of individuals surveyed to start with, then once we have the diagram fully labeled, we need to verify that if we were to add up all the values in every region, they add up to the total number of individuals surveyed. So here, that wasn't an issue because the diagram was already drawn. But if the diagram is not already drawn, then that's going to be something important to verify. So we'll get to that. We'll look at that in just a minute. We'll talk about how you label the diagram. The other thing I want to point out here is the questions. How were the questions for the survey structured? Notice that both of the questions were yes/no questions. The question was not, what kinds of music do you listen to? The problem with a question like that is it's an open-ended question. There's no way you can anticipate all the different answers that someone could give. You could have all people saying they have one type of music that they like, and then you survey another person and they give a totally different type of music. Maybe they list something that you've never even heard of. So the problem with a question like that is that kind of question, we can't actually represent its data in a Venn diagram. Venn diagrams represent sets that either someone does fall into or does not fall into. So when we ask the question, do you listen to classical music? If the answer is yes, then you fall into the set for those who like classical music. If the answer is no, then that means you fall out of that set for people who listen to classical music. So all the questions we write are going to have to be binary. They may not necessarily be yes, no, but they have to be you answer one way or you answer the other way. It can't be open-ended where someone just supplies their own answer, which isn't a yes or no kind of answer. So it's going to be important that we structure questions in such a way that someone either falls into a set or falls out of a set, and they can't end up in a variety of sets just based on how they answer. So let's talk about how we would actually solve a problem like this from start to finish using a diagram when we aren't already given one. So here's the general idea. Here are the steps we're going to follow every time. So based on the survey's description, the kinds of questions we're being asked, the kind of data we're interested in, we're going to define our sets. Okay, so we want to define our sets based on the things we're interested in. So for the last one, we were interested in people's feelings about classical music. We were interested in their feelings about jazz. And so we had a set for classical music. We had a set for jazz. The Venn diagram was drawn based upon the definition of those sets. And we had the overlapping region to represent the possibility that someone said that yes, they like both. So we define our sets. We draw our Venn diagram based on how these sets are defined. Now, one thing you have to keep in mind as you define your sets, sometimes it will be pretty obvious what the sets are going to be. Sometimes it won't be. But what we're going to have to be careful about is we have to make sure that we're only defining sets that really fit a Venn diagram. So the largest Venn diagram we looked at was a 3-circle Venn diagram. The only problems we're going to see are ones that can either be represented with 2 circles or with 3 circles. So if you're reading your problem description and you feel like you're going to need more than 3 sets, then that means you're probably not defining sets in the most efficient way. So we'll look at an example where initially it might seem like you need more sets than you really do, and we'll talk about how you work around that and identify sets so that you can draw a Venn diagram a little bit more efficiently. Okay, once you have your sets determined, you have your diagram drawn, you're going to use the survey results to determine the cardinality of each region. In other words, to determine how many respondents, how many individuals fall into the regions in your diagram. Now you're going to have to determine these values in a specific order. You're always going to start with the intersections. And if there's more than one intersection, for instance, if you have 3 circles, we have 4 intersecting regions. You're always going to start with the innermost region, and then you're going to work your way outward. So for instance, for a 3-circle diagram, you start with the region where all 3 circles overlap. Then you'll look at the regions where only 2 circles overlap, and then you'll look at the regions where there is no overlap among the sets. So you're always going to start from the very middle, and you're going to work your way outward. And then once you have your diagram, you essentially have it exactly like we had it for the last problem. And then as I mentioned, typically here we're going to be told how many individuals are surveyed. So before you start using your diagram to determine what you're looking at, to think about what you're looking at, you want to verify that your diagram is accurate in the sense that the count is correct. So if you were to add up all the different numbers that you've labeled in your diagram, then they should add up to the total number of individuals surveyed. If they don't, more than likely that means somehow you've overlapped a region that didn't overlap, or you haven't taken care of that issue with counting a union, those kinds of things. We'll talk about those kind of issues as we go. What sort of pitfalls might there be? But do double check that all the regions in your diagram, all the numbers you've written, add up to the total that you're supposed to have for the survey. And then once you have a diagram, again, you can just interpret from there just based on what your diagram is telling you. So let's look at a simple example. A survey of 120 college students was taken at registration. Of those surveyed, 75 students registered for a math course, 65 registered for an English course, and 40 registered for both math and English. We want to illustrate the survey results with a Venn diagram, and then we'll answer the questions based on our diagram. Okay, now let's be very, very careful about wording. When it tells you who registered for what course, it says 75 students registered for a math course. It does not say that 75 students registered for only a math course or for a math course exclusively. If you don't see anything like that, if you don't see anything like the word only or exclusively, that means that 75 is a total. It means that 75 students in total registered for a math course. 65 students in total registered for an English course. So we can't make any assumptions based on wording that we think should be there but isn't there. We have to interpret everything in extremely literal ways. Now, what we have been given is how many people registered for both. So as long as we know how many fall into that both category, we can determine the only categories as well, the exclusive categories. And then we also have been told that 120 people were surveyed. We have a survey of 120 people. So we know that when the diagram is fully filled in, all of the numbers, all the labeled regions should add up to a total of 120. So we're going to start by defining the sets. You have to think of them as sets that someone either does fall into or does not fall into. And notice again in this case, we weren't looking at what classes did you register for. We weren't surveying students and asking what classes did you register for. If you think of it as being questions, we asked two questions. We asked, did you register for a math class? Yes or no. And did you register for an English class? Yes or no. So anyone who registered for history or chemistry, psychology, anything else, that's not being considered here. We're just considering, did you register for math? Yes or no. Did you register for English? Yes or no. Now that's going to give us our two sets though. So the first set we're going to define represents students who registered for math. So maybe we'll label it with an M just so we know it represents math. The second set is going to be students who registered for English, so that's going to be E. So notice you either would fall into or out of the set for M. You would either fall into or out of the set for E, depending upon where you fell within these survey results. Okay, so once we have our sets, we're going to label our circles. Since we only have two sets, we need two circles. And don't forget that external region representing the universal set. Now, what does the universal set represent here? It represents all the students that were surveyed. It represents all 120. That's why all the regions within that universal set have to add up to be 120, because we're thinking of those 120 students as being our universal set here. So now we want to know, what are the counts for the specific regions in this diagram? We're always going to start in the very middle. Any regions representing an intersection, that's where we're going to start. So here's our intersection. It's where math and English intersect. So what could we say about anyone who falls into this region? Well, anyone who falls into that region, we know they had to register for math and they had to register for English. So that's going to be the region of students that registered for both. Now, we've been told that 40 registered for both math and English. So that means 40 students are going to fall into that region. Now, once we have the intersection, we're going to work our way outward. So let's start over here. This is the region representative of the math circle, but it's the region where we didn't overlap with the English circle. So what we could say about a person in this region is that they registered for math, but they didn't register for English. Now, what we know about math, we know 75 students in total registered for math. Now, one thing we have to keep in mind is that 75 students includes the 40 that registered for both, because the 75 is a total. So 75 students in total registered for math, 40 registered for both. So how many registered for math exclusively? Well, the way we can get that is by subtracting. So we know 75 in total registered for math. 40 of those students have already been counted because they were in the intersection. So we're going to subtract out those 40 people, which is going to leave us with 35. So that means 35 students in total registered for math exclusively. Now notice, if you look at that circle, look at the two labels. We have 35, we have 40. So if you were to take 35, add it to 40, we get 75, and 75 is our total for math. So it makes sense, this labeling makes sense. 40 registered for both, 35 registered for only math, so 75 in total registered for math and fall into that math circle. Now 65 registered for English, but again, 40 of those 65 have already been counted. So if we subtract 65 minus the 40 that have already been counted, then that's going to give us 25 students that registered exclusively for English and are going to fall in that region of the diagram. Well, who are we leaving out? It's possible that we surveyed someone and they said, no, I didn't register for math, no, I didn't register for English, I registered for other things. So what we still need to determine is who falls outside of these sets. So they're within the universal set in the sense that they were surveyed, but they didn't fall into either of these subsets, this math set, this English set. Well, here's where we're going to use the total. We surveyed a total of 120 students. Some of those students have already been categorized. We've categorized 35 of them, 40 of them, and then an additional 25 of them. So if we've categorized this many students, how many are left over out of that total of 120? So again, we can work backwards. We can subtract from 120. So from 120, we subtract all of the individuals that have already been categorized. So minus 35, minus 40, minus 25, and that's going to give us a total of 20. So those are the remaining students that weren't already categorized into one of these subsets. So that's going to be the number that's within the universal set, but not further categorized into the math or the English set. Now again, before we use the diagram, we want to double check that all of these regions added together gives us the correct total for the number of survey respondents. We do want to double check that. So 35 plus 40 plus 25 plus 20, and sure enough, that adds up to 120. That is not a guarantee that the diagram is correct, but it's a confirmation that at least the numbers make sense. If the numbers don't even make sense, then we know the diagram for sure is not correct. If the numbers make sense and the totals fit the way they're supposed to, then more than likely the diagram is correct. So based on this diagram, let's answer a few questions. Question 1, how many students registered for math? Now again, read the question carefully. It doesn't say how many students registered only for math. It says how many said yes to the question, I registered for math. Well, we actually have the total in the description, but we can also determine it from the diagram. In terms of the math circle, a total of 75 individuals fall somewhere within that math circle. So 75 individuals registered for math. How many registered for only English? Here's that special wording. Now we're asking English but not math. How many said yes, I registered for English, but then said no, I did not register for math? In terms of the regions in the diagram, that means they fall into the English circle, but they don't fall into the region that overlaps with the math circle. So that means there's going to be 25 that registered for only English. Okay, how many registered for math or English? Remember, or means we're taking the union. So if they registered for math, we're going to keep them. If they registered for English, we're going to keep them. If they registered for both, they're also going to be included in this set. So that's going to be the combination of our two circles. Anyone that falls anywhere within those two circles is included as part of this union. So 35, 40, and 25 in total adds up to 100. So a total of 100 students are taking math or English or possibly both. And then the last question, how many did not register for math or English? The word not here, we can think of that as the complement. Math or English is the union of these two. So we're taking the complement of the union, which means we're removing those two sets from the diagram. Well, what's left if we remove those two sets? That's going to be 20. And so the individuals who didn't register for math or English, those are represented as members of the universal set, but not members of either the math set or the English set. And that's going to be a total of 20. Let's look at another one. Now, this is one I mentioned a moment ago. Sometimes it's not always obvious what the sets you want to define are going to be. Sometimes it looks like you need more sets than you really do. So you're going to have to be a little bit more creative. So this one's a little bit long. We'll break it down step by step. So a survey was taken that asked 1,700 randomly selected US and French adults to agree or disagree with the following statement: "It is the responsibility of the government to reduce income differences." The results of the survey showed that 1,040 people in total agreed with the statement. 290 Americans agreed with the statement. If 810 adults surveyed were American, we want to answer 2 questions, and we'll worry about these questions in just a moment. What are the actual questions? We don't need to know what they are yet. So what are we going to define as our sets? Well, let's look at the survey results. Here are the things we're interested in. We're interested in whether or not someone is US or French, whether they're American or French, and whether they agreed or disagreed. So at first glance, it almost looks like there are 4 sets involved here. There's the set of people that are American, there's the set of people that are French, there's the set of people that agree, there's the set of people that disagree. Okay, now there are 4 distinct categorizations, but there are not 4 sets involved here. We don't even know how to draw a diagram for 4 sets. It's not as simple as draw 4 circles and overlap them the way you overlap 2 circles and 3 circles. Unfortunately, it's just not that simple. So we're limited to either 2 sets or 3 sets. Now here it turns out we only need 2 sets. And I want you to think of how these sets work. Whenever we define a set, we draw a circle in a Venn diagram. We're talking about categories that either someone falls into or falls out of. Now here, we can think more broadly about US versus French. Another way of saying that is nationality. So you either fall into one nationality or you fall into the other nationality. We can also define sort of broadly agreement. You either agree or you disagree. So that's going to put us into 2 major categories. So if we can think in terms of those 2 major categories, then we can probably define our sets just using 2 circles, doing a diagram with 2 circles. Now we can't necessarily say nationality exclusively, agreement exclusively, because then that breaks us down into 2 categories. But we want to define nationality as you either fall into this category or you fall out of this category. So one way of doing that is to say, maybe we think of one set as being the American set. Why is that probably a good idea? Well, notice we're given specific information about Americans. We know 290 Americans agreed, 810 Americans were surveyed. We have information about all the respondents who were American. So if we define one of our sets as the set of Americans, think about what it means. If you fall into the set, you're an American. What happens if you fall out of that set? Well, based on how this survey is structured, we know you're either American or you're French. So if you don't fall into the set of Americans, if you're outside of that circle, then automatically that just means you have to be French. So in order to represent the nationality component of this survey, we can define one of our sets as the set A, if we want to think of the set A as being American. I think I used A. No, I used US. We're going to use A for something different. So we'll call US the set of Americans that are surveyed. And again, that's going to work because either you fall into that set, which means you're an American, or you fall out of that set, which means you have to be French, because only 2 nationalities were surveyed in this case. So that's going to take care of the nationality issue. Now the other issue here is agreement. Either people agreed, yes, I agree with this statement, or they said, no, I disagree with this statement. So kind of like American, you fall in, you're one category. If you fall out, you have to be French. Same kind of thing here. So what do we also have information about? We have information about agreement. So if we define our other set as the set of people who agree, if you fall into that set, you said, yes, I agree with the statement. If you fall out of that set, you said, no, I disagree with this statement. So that's going to take care of our other 2 situations. So that's going to be our second set. And notice again, that covers all 4 different situations. If you fall into the US set, you're an American. If you fall out of it, you're French. If you fall into the set A, you agree. If you fall out of it, you disagree. And that covers all 4 different possibilities, all 4 different situations based on how the survey is being described. So those are going to be the 2 circles we have overlapping. And notice it's not necessarily obvious at the very beginning that those are the circles, those are the sets we're going to define. You have to base it on the kind of data you have. Look at the actual results. What sort of things do you have information about? If you can identify things that you have information about, where either someone falls into a category or falls out of a category, that's going to give you the most information about how you're going to define your sets. So what we now need to determine is what the regions represent and how many individuals fall into each region. We're always going to start with the innermost region, which is our intersection. So we have the US circle, we have the agreement circle. So what can we say about anyone who falls in the middle? Well, they fall into the US circle, so they're American, and they fall into the agreement circle, so they agree. So anyone who falls in the middle is going to be an American who agreed with the statement. So let's see if we can identify who that's going to be. We actually have a number here that tells us 290 Americans agreed with the statement. So that represents the overlap of the American set and the agreement set. So our innermost region, that's going to be 290. Now we also have to look at the other 2 sets, the Americans and then the agreement set, the other regions. Okay, so our first statement was 1,040 people agreed with the statement. Okay, 1,040 in total agreed with the statement. So the agreement circle needs to total up to 1,040. Well, we already have 290 of that 1,040. So if we subtract 1,040 minus the 290 that we've already labeled, that's going to give us 750. So the remaining region of that circle has 750 in total. What about the US circle? Okay, what's the other piece of information we have? So we've used both of these pieces of information. We were also told that 810 adults surveyed were Americans. Okay, 810 Americans in total. So that means the total for the American circle, for the US circle, has to be 810. Well, we already took care of 290 of that 810. So the difference, 810 minus the 290, we already categorized, is going to give us the remaining number in the circle, which is 520. So we've labeled 3 of the sections in the diagram. What's left over? Well, we also have to consider the region outside of the circles, but still within the diagram, everything that's left over. This is where we go to the total for the survey. So we were told that 1,700 individuals were surveyed, a total of 1,700, and they either were American or French, they either agreed or disagreed, 1,700 in total. We've already categorized a portion of those. We've categorized 520, 290, and 750 of them. So how many are left over out of that 1,700? Well, 1,700 minus the 520, minus the 290, minus the 750, that's going to give us 140. So the external region, people that fell into the universal set but didn't fall into one of these categorizations, that's going to be 140 in total. So before we look at the questions, I want to think about what these regions really represent, because it's not as simple as you fall into math, you fall into English, so you registered for both. Because remember, our sets were not as obvious in this case. So I want to go region by region and think about what each of these regions represent. So let's start in the very middle, our intersection. So if you fall into the intersection, you fell into the US category, which means you're an American, and you fell into the agreement category, which means you were in agreement. So in the innermost section, that's going to be Americans who agreed. Now, what if you fall into the US circle, but you fall into the rest of it? Which means you're an American, but you don't fall into the category of agreement. Well, if that's the case, if you don't fall into the category of agreement, then that means this region represents Americans who disagreed. So they are American, but they aren't in agreement. So these are going to be Americans who disagreed. Well, what if you fall into this region? So that's going to be people who agreed but didn't fall into the American category. So they agreed, but they didn't fall into the American category. That means they have to be French. Remember, we only surveyed 2 nationalities here. We surveyed Americans and we surveyed French citizens. So they agreed, but they weren't American, means these are individuals that are in agreement, but are French. They're the opposite of American in this situation. Now, what about the external region? What about the leftovers? Well, anyone out here wasn't American and didn't agree. Well, if they're not American, that means they're French. If they're not in agreement, that means they're in disagreement. So that means everyone on the outside is French and they disagreed. So Americans who agreed, Americans who disagreed, French people who agreed, and French people who disagreed. You want to take the time each time you draw the diagram to really think about what regions represent what. What would we say about anyone who falls into a particular region, particularly for a more complicated situation like this one? So now that we know what our regions represent, let's answer a couple of questions. So the first question, how many French adults agreed with the statement? In other words, they don't fall into the American category, they're French, but they do fall into the agreement category. So agreement, but not American, that's going to be 750. So 750 French adults agreed with the statement. And then the next question, how many French adults disagreed with the statement? So they're French, they fall out of the American category. They're in disagreement, so they fall out of the agreement category. And remember, that was everyone left over in the diagram, which is a total of 140. So 140 French adults disagreed with the statement. So definitely a little bit more complicated than the one before. But again, if you break it down, think of categories that you either fall into or fall out of, yes or no kind of things, then that's going to help you define your sets, and then you can go from there. Now let's look at what happens if you have 3 sets, if you have to use a diagram that has 3 circles. The hardest part here is going to be labeling them, being organized enough to label them. Remember, you always start at the very middle and then you work your way outward from there. So it's going to be more important than ever here to think about what the regions really represent, because that's going to help you label your diagram. So 60 people were contacted and they responded to a movie survey. The following information was obtained. So 6 people liked comedies, dramas, and sci-fi. 13 people liked comedies and dramas. 10 people liked comedies and sci-fi. 11 people liked dramas and sci-fi. 26 people liked comedies. 21 people liked dramas. And then 25 people liked sci-fi. So we want to draw a Venn diagram, use it to answer the questions. Well, the sets here are a little bit easier to define. We asked 3 questions. We can think of it as asking 3 questions. Do you like comedies? Yes or no. Do you like dramas? Yes or no. Do you like sci-fi? Yes or no. Depending on how anyone answered, they either fall into one of those sets or they fall out of those sets. So our sets we can call C, D, and S. And I'm going to label it in this order. You might want to label it in this order just so we have the numbers in the same area. But keep in mind, the order you label them in does not actually matter. It means you might be looking at different regions in the diagram, but your diagram still communicates the same information. Now you might be thinking, well, 6 people liked all 3 of them. 13, 10, and 11 liked 2 of them. 26, 21, and 25 only liked 1 category. But what happens if you add up all the numbers you have in the list? Let's see what you get. So 6 plus 13 plus 10 plus 11 plus 26 plus 21 plus 25, 112. What's the problem with that number? Well, how many people were surveyed? We were actually told that. We were told that 60 people were surveyed. But if we add up all these numbers, they add up to a total of 112, which is more than the people that were actually surveyed. This is saying 112 people were surveyed. Well, the reason this total adds up to more than it should is because these numbers don't represent individual categories. Only one of those numbers represents an individual category. The only number like that is the number 6. 6 people liked comedies, dramas, and sci-fi. The rest of the numbers are totals. Remember this distinction between having the word only and not having the word only. We were told that 13 people liked comedies and dramas. This does not say that 13 people liked only comedies and dramas. What this means is that 13 people in total liked comedies and dramas. In other words, they fell somewhere in the overlap of the comedy and drama categories. So again, we have to work backwards. We start in the middle, we work backwards, keeping in mind that these larger values are totals for specific regions. And so every time we label a particular region working our way outward, we have to consider the parts of our circle or our circles that have already been labeled. We have to take that into account. And we also know at the very end, it should all add up to 60 if we look at the entire diagram. So we do need to verify that as we go. So we've labeled our circles. We know there's 3 categories, so there's 3 circles. So let's start in the middle. 6 people liked comedies, dramas, and sci-fi. So that's going to be the innermost region. That's where the 3 circles overlap, and the one region you have that in is in the very center. So 6 people will fall into that region in the very center. So if you have your own paper, you might want to check off the numbers as you go. We have to use all of these numbers, but once you've used one, you've labeled a region. So we've used the number 6. Now we'll base everything else on what we put in the diagram. So next thing we know is that 13 people liked comedies and dramas. So in total, 13 fell into the comedies category and the dramas category. In other words, the region where comedies and drama overlap. 13 people in total liked comedies and drama. Well, 6 people have already been labeled. So to get to our total of 13, we would need 7 more. So the 7 and 6 together give us the 13 in total that liked comedies and dramas. 10 people liked comedies and sci-fi, so comedies and sci-fi. 10 people like both of them. Again, 6 have already been taken care of, so that means there are a remainder of 4 that only like comedies and sci-fi. So anyone in the very center likes all 3. Anyone right here only likes those 2 categories. Okay, 11 people like dramas and sci-fi, so dramas and sci-fi. So we're looking at that overlapping region. 11 in total, 6 have already been covered. So we need an additional 5 that exclusively like these 2 categories. Now that covers all of the intersections. So how many people do we have so far? We'll have 6, 4, so that's 10, and the 17, and then 22. So we have 22 out of the 60 people already labeled. So everyone else out of that 60, the remaining individuals either fall into one of these regions or they fall into the universal set but not into one of these subsets. So our next number, 26 people liked comedies. In other words, the circle for comedies should total up to 26. Now here we'll probably have to do it in the calculator. Notice how many regions related to comedies have already been labeled. So if we look at the comedies circle, it's broken down into 4 regions. 1, 2, 3, 4. 3 of those regions were already labeled. So we need to know what's going to be in the last region in order to give us our total of 26. So 26 minus the numbers that we already have, the regions that have already been labeled. So minus 7, minus 6, minus 4, and that's going to give us 9. So 9 individuals fall into this region within the comedy circle other than the regions that have already been labeled. Okay, 21 people in total liked dramas. So 21 should be the total for the drama circle. 7, 6, and 5 have already been labeled. So 21 minus 7 minus 6 minus 5, and that's going to give us a remainder of 3. And then last but not least, 25 liked sci-fi. So the total for sci-fi should be 25. We already have labeled 4, 6, and 5. So 25 minus 4 minus 6 minus 5, and that's going to give us 10. So 10 is going to be the remainder left over. Now let's see what all we've categorized so far, because that's going to take us close to 60. If it takes us over 60, then that means there's a problem. It means somehow the arithmetic didn't add up. We need to go back and double check our numbers, because 60 should be the total for all the regions in this diagram. So if we add up everything we've labeled so far, we have 9 plus 7 plus 3 going straight across, plus 4 plus 6 plus 5 plus 10. And that's going to give us a total of 44. So in terms of individuals categorized into some region within the circles and their overlap, we have 44. That's going to help us with the rest of it, because we know that 60 individuals were surveyed. Now it's possible they were asked these 3 questions: do you like comedies, do you like dramas, do you like sci-fi? It's possible they said no to all of them. Maybe they just like horror films, maybe that's their thing. So out of those 60, 44 have already been grouped. They've already been assigned a region. So who's left over? Well, 60 minus the 44 who've already been categorized leaves us over with 16. So 16 is going to be the value that goes into the universal set outside of our subsets. Now there's a lot of labeling here, there's a lot of numbers. So before we actually use the diagram, again, we want to double check, do all of these numbers add up to give us a total of 60? Let's make sure. So 9 plus 7 plus 3 plus 4 plus 6 plus 5 plus 10 plus 16. And sure enough, that adds up to give us 60. Now again, that's not a guarantee that the diagram is correct, but at least it guarantees that the numbers make sense and they add up to the total that they should. So based on our diagram, let's answer a few questions. First question, how many people liked comedies, but neither dramas nor sci-fi? So in other words, they fall into the comedies circle, but they don't fall into the dramas and the sci-fi circles. So you can think of complementing those, omitting those. Well, that's going to leave us with 9 individuals in the comedy circle, the ones who do not like dramas and do not like sci-fi. Okay, next question. How many people liked dramas and, careful with your wording, and sci-fi, but not comedies? So dramas and sci-fi, we're looking at the overlap, but not comedies. Well, that's going to leave us with 5 in the overlap. So dramas and sci-fi, but not comedies. Take comedies out of the picture. So that's going to leave us with 5. Okay, how many people liked dramas or sci-fi, but not comedies? It looks like the same question, but what's changed? The word and became the word or. Remember, and means intersection, or means union. So now we're looking at the union of dramas and sci-fi. We're looking at that whole set formed if we take the dramas category and the sci-fi category and we join them together. But what else? We also know they don't like comedies. So again, we want to omit the category of individuals who like comedies. So that's going to leave us with 3, 5, and 10 in terms of the regions that we'll keep. So 3 plus 5 plus 10, that's going to give us a total of 18. How many people liked exactly one movie genre? Now what that means is that now we're no longer looking at overlap. So anyone who falls into one of the overlapping regions liked at least 2 categories. They liked maybe comedies and drama, maybe comedies and sci-fi, maybe drama and sci-fi, or maybe they liked all 3. So in terms of the people who liked one category exclusively, those are going to be the regions within each circle that don't constitute any overlap. So we have 9, 3, and 10, which totals up to give us 22. How many people liked at least 2 movie genres? Well, again, at least 2. Now we're thinking about the intersection. We're thinking about maybe 2 specifically, or possibly all 3. So that's going to be our overlapping regions. So 7, 4, 6, and 5. So 4 and 6 adds up to 10. 7 and 5 adds up to 12. So that's going to give us a total of 22. And then the last question, how many people liked none of the given movie genres? And that's going to be that region that we labeled on the outside. So those are the individuals who were surveyed but didn't fall into any of these categories, which means they said, no, I don't like this kind of movie. Now again, like with the math and English registration type problem, I want you to think about how these questions had to be structured. They were yes, no questions. So anyone who took this survey responded to 3 questions. The first question was, do you like comedies? The second question was, do you like dramas? And the third question was, do you like sci-fi? They could not have been asked the question, what kinds of movies do you like? That is an open-ended question. You can't fall into a category or fall out of a category based on an open-ended question. With an open-ended question, they could answer however they liked. Now, if, for instance, maybe that question was asked and the only responses were some combination of comedies, dramas, and sci-fi, then maybe you could work with that. But in general, you don't want to use an open-ended question to define the regions in a Venn diagram, just because you can't predict what people are going to say. It's not yes, no. It's not you fall into a category or you fall out of a category. So anytime we're defining the questions that we're going to use in the survey, they've got to be strictly yes or no questions. You either fall into this set or you fall out of this set. Okay, let's look at one last example. Okay, a survey of 180 college men was taken to determine participation in various campus activities. 43 students were in fraternities, 52 participated in campus sports, and 35 participated in various campus tutorial programs. 13 were in fraternities and sports, 14 were in sports and tutorial programs, and 12 were in fraternities and tutorial programs. And then 5 students participated in all 3 activities. So we want to draw our diagram, answer some questions from our diagram. Okay, what are our sets here? Think about the different things that would have been asked. We weren't asking them, what do you do on campus? We asked them 3 questions. Number 1, are you in a fraternity? Number 2, do you participate in campus sports? And number 3, do you participate in tutoring? So those are going to represent our 3 sets here. So let's call them F, S, and T, so it's easy to identify which one is which. So because we have 3 sets, we need 3 circles. Okay, now as we label, we start in the very center. What could we say about someone in the very center? Well, we know that anyone in the very center is in a fraternity, plays sports, and does tutoring. So that's going to be anyone that participates in all 3 activities. So how many individuals participate in all 3 activities? Well, we were told that 5 students do. So 5 students participate in all 3 activities. Now, just like with the last example, that's going to be the only value that directly identifies the number in a region. All of the other values represent totals for regions, for combinations of regions. So for instance, when I see the number 43 students were in fraternities, that means 43 students in total were in fraternities. The fraternity circle has a total of 43 within the combination of its 4 individual regions. So this is why we're working backwards. So we know that 5 participate in all 3 activities. Now we want to know how many participate in 2 activities exclusively. So we're starting there. Now let's work backwards. So 12 are in fraternities and tutoring. So fraternities and tutoring, and means intersection. So fraternities and tutoring, we should have a total of 12. Well, 5 have already been categorized because they participate in all 3, which means that we need an additional 7, which only do fraternities and tutoring. Okay. 14 are in sports and tutorials. 14. So sports and tutorials, a total of 14. 5 have already been listed, so we need an additional 9 that only do these 2 activities exclusively. Okay, and then 13 are in fraternities and sports. So fraternities and sports, both of them, 13 in total. 5 have already been taken care of, so we need the additional 8. And that's going to label all of our overlapping regions. Now we can go to our totals. So our totals for each circle are 43, 52, and 35. So 43 students were in fraternities. In other words, the fraternities circle should total up to 43. Now we've already labeled 8, 5, and 7. So we want to see what's left over. So a total of 43 minus the individuals who are already listed. So minus 8, minus 5, minus 7, and that's going to give us 23 in the F circle exclusively. Okay, 52 are in campus sports. So in the campus sports one, we have a total of 52. We've already labeled 8, 5, and 9. So 52 minus 8 minus 5 minus 9, and that's going to leave us with 30. And then 35 are in tutorial programs. We've already taken care of 7, 5, and 9. So 35, about to write 45. 35 minus 7 minus 5 minus 9. That's going to give us what we need left over, and that's going to be a total of 14. Okay, so that labels all the circles, all the regions within the circles. That's 7 out of the 8 regions in the diagram. What about everyone left over? Remember, there's a grand total of 180. So how many individuals have we already categorized? Let's see. In other words, anyone who falls anywhere within the actual subsets, how many people do we have so far? So we have 23 plus 8 plus 30 plus 7 plus 5 plus 9 plus 14. And so that gives us 96 so far. Well, we know 180 people were surveyed. Only 96 of them have already been categorized. So who's left over? Well, 180 minus 96 leaves us with 84. So that means 84 individuals are in the universal set but weren't categorized into one of these 3 subsets. Now, just to double check, let's do one last addition. Let's make sure that all of these values add up to give us 180. So 23 plus 8 plus 30 plus 7 plus 5 plus 9 plus 14 plus 84, and that's going to give us a total of 180, which is the total that we're supposed to get. Okay, now let's answer our questions. First question, how many students participated in only sports? So sports exclusively. So they fall into the sports category, but they don't fall into the fraternities and the tutoring categories. So that's going to leave us with 30. So 30 students participate in only sports. How many participated in fraternities and sports, but not tutoring? So fraternities and sports, so the overlapping region, but not tutoring. Well, that's going to leave us with 8. So 8 are in both, but not in tutoring. So 8 in total. How many participated in fraternities or sports, but not tutoring? Again, the only word change here is and became or. So and means intersection, or means union. So the union of fraternities and sports. Take these 2 circles, join them together. Think of that as one big set of individuals, but not tutoring. So we're looking at this whole set, but we're removing the individuals who did tutoring. So that's going to be 23 and 8 and 30, which adds up to give us 61. Okay, how many participated in exactly one activity? In other words, they fell into one circle exclusively. They didn't fall into an overlapping region. We have 23, 30, and 14, which is going to give us 67. And then how many participated in at least 2 activities? In other words, they were in some type of overlapping region. Well, we have 8, that's fraternities and sports only. 7, fraternities and tutoring only. 9, sports and tutoring only. And then 5 students participated in all 3 to give us a total of 29. And then our last question, how many did not participate in any of the given activities? That's going to be anyone who didn't fall within one of those regions, and that's going to give us 84. Now, in terms of what that 84 means, it does not necessarily mean that they didn't do anything. It doesn't mean that they just did their homework and sat at home. All it means is that they didn't do one of these 3 activities. So we can't extrapolate more than what the questions actually tell us. We can't assume based on additional information that the questions don't give us. Because again, the questions are yes or no. Are you in a fraternity? Yes or no. Do you participate in sports? Yes or no. Do you participate in tutoring? Yes or no. We don't have any information about any additional types of activities that these students might do on campus. Maybe they're in a club. We don't have information about that from this survey because again, we can't ask open-ended questions where a student can answer any type of answer other than these. We just can't anticipate what anyone's going to say, and so that kind of information is not well suited to a Venn diagram. So hopefully this gives you a sense of how you might use a Venn diagram in the context of an actual problem. It's really just used as a visual to organize our data. So all the data we need is listed right here, but it's not very meaningful looking at data in that sense. Having data in this kind of form makes it more meaningful. So for instance, we can see that in terms of participating in one activity, more students participated in sports exclusively than fraternities or tutoring exclusively. So something like that, for instance, we can determine from the diagram, but we can't readily determine just looking at a list of data points. So a Venn diagram can be useful, and hopefully you can see some of these set operations represented looking at the diagram.